Now, what are access ports? Well, as you can see, all of our interfaces are still access ports. Yeah, all of our interfaces. Okay, let's name it. Access ports. So, E1, E3. This is E3, right? This is E3 connected to server C. So E1, E3, what else? E8 of switch 1. These are access ports. And we configure these three interfaces of switch 1 to VLAN 1. Excuse me, VLAN 10. Now, we also have okay, let me correct this. It should be E1 and E3. Okay, E1 and E3 connected to PCA and server C, and then E2 and E4 and E8. These are configured as VLAN 20. Okay, sorry, this should be E9. There you go. Now, as you can see, E1, E3, and E8 connected to PCA, server C, and to switch 2, they are configured as VLAN 10. Only one VLAN, okay? For interface E2, E4, and E9, these are all configured as VLAN 20. Only one VLAN. And this interface or access ports is okay. This is actually the default interfaces, okay? And we're using access ports primarily if you're connecting endpoint devices to your switch, okay? But it's not a good idea to use access ports from one switch to another, okay? Here's the reason. In this topology, we have two uplinks. One is for VLAN 10 and one is VLAN 20. Is it a good design? Well, in this case, even if it's small, we only have two switches and few active ports, is still a bad design, okay? What more for a large environment? What more if you have multiple VLANs, not just two, not just three VLANs, okay? And what if you have multiple endpoint devices, multiple PCs, multiple servers, and other endpoints such as printers, IP phones, scanners, cameras, etc. The reason why it is considered bad design is because if we increase the number of VLANs and we need to forward traffic from one switch to another, we will be wasting many uplink ports. Just imagine, let's say you have VLANs 10 to VLANs 20. So that is a total of 11 VLANs. VLAN 10, 11, 12, up to 20. So are you saying that we will be creating 11 uplinks from switch 1 to switch 2? Bad idea. Now, the better approach is this. Instead of multiple interface connecting to switch 1 to switch 2, I'm gonna erase E9 because we don't need E9, okay? Here's what I'm gonna do. I will just use excuse me, I will just use one interface connecting switch 1 and switch 2. Yes, we don't need multiple uplinks. We just need one uplink. And this is called, well, in Cisco it's called trunk. In other vendors it is called tagged ports. But regardless of its terminology, the goal is it carries multiple VLANs, okay? And also, trunk and tag, these are terminologies used by vendors. The protocol that is being used is really 802.1q, okay? So this interface is using 802.1q protocol. Now, by looking at our VLAN database, we have VLAN 1, what else? VLAN 10, and VLAN 20. Okay, so these VLANs are all carried in this single trunk tag or 802.1 uplink. Now, this is what's gonna happen. If PCA needs to forward the traffic to server E, it will forward the traffic to all VLAN interfaces. Not only VLAN interfaces, or should I say VLAN 10 access ports, it will also forward it to trunk ports. Now, the trunk port, we're not gonna go to the details of Ethernet header with the tag field. Basically, what's gonna happen is it will forward it to this trunk link. It will be received by the interface of switch 2, and switch 2 will process it by forwarding this traffic to the interfaces that is configured as VLAN 10. So in this case, this interface connected to server E is configured as VLAN 10. Okay. Now this goes the same with PCB. PCB, let's say the destination is still unknown. It will do broadcast, and it will not only do the broadcast to interface E4 of switch 1, it will extend the broadcast to the trunk link, and it is destined to switch 2. Switch 2 will forward the broadcast to all interfaces configured as VLAN 20 until it reaches the destination server F. Now, let me highlight something. Remember, I mentioned that 802.1q, by default, it will carry all VLANs. But in this case, we only have 3 VLANs configured. Actually, VLAN 1 is not configured. It's already there in the database by default. So we have 3 total number of VLANs, 2 created VLANs. Now, by default, 802.1q or the trunk link will carry all these. Okay? But since we only have 3 VLANs in the database, this is what is only gonna use. But the question is, can we limit the VLANs that is carried or used by the 802.1q interfaces or the trunk interfaces? Absolutely. You can always limit the allowed VLANs in your 802.1q ports.